Here we have some special integral properties. Now that's kind of my special way of saying these are the things that don't look so bad but are actually the things that make everything super tricky. So let's start off with if we see two functions added together inside an integral. So we're looking for the antiderivative of x squared plus x cubed. So what can we do with something like that? Well, the rule that we're going to see is that we can actually just take the antiderivative, the sum of the antiderivatives, right? So we can split up that integral across the sum. Now, so like what that means here is we don't have a formula for something like x squared plus x cubed, but because of this rule up here, because of this property 1, we can split this up into x squared dx plus x cubed dx, and from there we can use the formula we learned earlier on this and the formula we learned earlier on this, and we'll get something like x cubed over 3 plus x to the 4th over 4, and we actually end up with 1 plus c for the whole thing. Now, what about something like c times f of x? So this one down here, our example would be 5 would be our c, our f of x would be x squared. What can we do here? Well, it turns out kind of similar to derivatives. We're able to pull that c out. So we're going to have c times the antiderivative that we knew before. So what are we able to do down here? We're able to pull the 5 out. And from here, we're able to use the formula again that we knew from before. So we'll get the 5x cubed over 3 and then a plus c for the whole thing. Kind of in general, when you're doing antiderivatives and you have multiple ones, you just get one plus constant at the end. And the way I would simplify this one is 5/3 x cubed plus c. Now let's do some practice with these two properties because it doesn't look so bad right now, but it actually opens up a lot of doors for us. So the first one we'd see is something like finding the antiderivative of this polynomial, right? So we're looking for big H of t. We're looking for something where we can take the derivative and we'll get that. So we're really just looking for the integral of 3x squared plus 2x plus 7. Now, by my rules above, I can split this up into 3 different antiderivatives. So I'll get 3x squared plus dx plus the integral of 2x dx plus the integral of 7 dx. And now by my formulas here, not by the formulas, by the next property, I can pull that 3 out, right? So I'll get 3 integral of x cubed dx plus, I can pull the 2 out, 2 integral of x dx. And sorry, this is an x squared actually, I miscopied that. And then I don't need to pull anything out here because I actually have a rule for constants. And so after I apply my rules here, I'll get 3 times x cubed over 3 plus 2 times x squared over 2. Again, I'm just using my rules from before to do these integrals. And then my rule for 7 is 7x. And then 1 plus c for the whole thing. Now, so if I go ahead and simplify this, I'll get x cubed plus x squared plus 7x plus c. All right, and so this is this function here. You can come back and check. If I take the derivative of this, what I'll get is I will get 3x squared plus 2x plus 7, like I want. Okay, let's try one more here. So this looks a little bit bad, but again, let's use our properties, right? So we have two functions, and we can split it up. We'll have the integral of x to the 7th dx plus the integral of 2 over x dx. And this one I'll be able to use a formula right away. I can't use a formula yet right here, but what I can do is this 2, it's really 2 times 1 over x. And so I'm going to split this up like this. I'll leave this first integral the same. This next integral I'll write as 2 times 1 over x dx. Right? And so from here, again, it's just using the formulas that I learned earlier. So I'll have x to the 8th over 8. And then here I will have 2 ln of the absolute value of x. And that's just from the initial rules that we did in the first video. 1 plus c for the whole thing. And so just the big idea of what I'm doing here is when I'm adding, I can split it up into several problems, and if I multiply by a constant, I can pull that out. Let's try and look at one final one here. Just kind of get used to one more rule. I have a constant, so I'm going to pull that 9 out. I'll have 9 integral of e to the 2t dt. What about this 2? Is there anything I can do with that? The answer is no, but the good news is you don't need to. Remember our formula for e to the kt, we had a formula for e to the kt, so we can just do 9 times what we get from that formula, right? So 1 over 2 e to the 2t was our formula for e to the 2t. So k was equal to 2 here. Now I would have 1 plus c for the whole thing. Now simplifying that a little bit, I would end up with 9 halves e to the 2t plus c. And you can see that if I took the derivative of this, my 2 would drop down. I'd end up with 9e to the 2t, just like I wanted.